In this scene, the ball is thrown up into the air. The acceleration of gravity is always negative 10 meters per second squared, or negative 10 meters per second, and thus it is always acting on the motion of the ball. Once the ball is released from my hand, the acceleration of gravity is always acting on the ball, and there is only one acceleration, gravity. The velocity, however, is different. The velocity comes out of my hand at a certain speed and is constantly slowed by the acceleration of gravity. So, for instance, if the ball left my hand at 100 meters per second, it would slow at negative 10 meters per second every second. So, for instance, in 3 seconds, the ball will be at 70 meters per second. Once the ball reaches the top of the path, the velocity is zero, and it begins to decrease at a rate of negative 10 meters per second for the acceleration. So once the ball releases and hits the bottom of the path or at the ground level, the velocity is zero, and the acceleration would still be the same, or negative 10 meters per second squared. Here's an instant replay.
Here's our next experiment. In the second scene, we pass the ball towards the wall, and like in the first experiment, the acceleration is gravity at negative 10 meters per second squared. The ball is then released, and the velocity decreases until it hits the wall, where it is 0 meters per second. The ball rebounds back towards us, and then the ball falls towards Earth because of the gravity.
Here's an instant replay.
Here's our next experiment.
In this third scene, the continuation of our passing scenes, the ball is thrown straight up into the air. The forces acting on the ball are the same as the first scene, where gravity acts negatively on the velocity of the ball, or negative 10 meters per second squared, or negative 10 meters per second. The gravity slowed the ball down until its velocity reaches 0 meters per second, where the ball reaches the peak of its parabola, or at the top of its path. And then, at that point, and from there on after, the velocity is negative, and increasingly negative, at negative 10 meters per second squared. So, once the ball leaves my hand, the only acceleration is gravity, which is at negative 10 meters per second squared, and slows down the ball's velocity until the ball has reached 0 meters per second. Here's an instant replay.
Here's our next experiment.
In this fourth scene, the ball is dribbled. A force is applied upon the ball and is pushed back towards Earth. So every time we dribble the ball, and when it reaches the top of its path, I push the ball back towards Earth, or hit it back towards Earth. Acceleration is always constant in this scene at negative 10 meters per second squared, and that acceleration is also known as gravity. The acceleration pulls the ball back towards Earth, as well as the applied force of my hand pushing the ball back towards Earth. And when the ball bounces back towards Earth at 0, velocity is 0. Here's an instant replay.
Here's our next experiment. In the fifth scene, we roll the ball down the concrete path, and the ball slows down because of the friction on the concrete, and slows down even more because of the grass at the end of its path. Once the ball is released, the ball slows down, and it finally comes to a rest at some point in the grass.
This is because of the force of friction acting on the ball and the inertia of the ball. Because the ball is rolling, the friction acts against the ball's movement and slows the ball down until it finally comes to a rest. Here's an instant replay.
Thanks, Mr. Gardner, for watching our video. We hope we got an A.